chapter haloalkanes and haloarenes. So when we look into the chapter of haloalkanes and haloarenes, first it comes up with the naming of haloalkanes. So let's try to name haloalkane with some important FAQs, okay? So we will take a few examples from every important portions. We'll consider the FAQs and we'll discuss from the chapter, okay? So this is the first question. Write IUPAC name of the following compound. So this is the compound given. So we'll have an overall look into that compound. We can see here we have a double bond here, which is a functional group, which can be considered as a functional group, and we have Br here, that is also a functional group, and you know that the preference goes to double bond, and we have a substituent CH3 here. So the double bond, the parent functional group is going to be the double bond, and the Br and the CH3 will act as substituents. Okay, so we will start numbering it. So the preference goes to double bond. So we will start numbering from here. 1 carbon, number 1, 2, 3. Okay, so we can name it. So B comes first in the alphabetic order, right? So we will start with bromo. 3 bromo. 3 bromo. Then in the second position we have the substituent methyl group. 3 bromo, 2 methyl. How many carbon atoms are here? 1, 2, 3. Prop. 3 bromo, 2 methyl, propene or prop1ene. Propene or prop1ene. So this is the name of the given compound. Okay, 3 bromo, 2 methyl, propene. So you have already learned about the rules of naming, and what we have to be careful about is you should be able to identify the functional group present and the substituents present, and you have to identify which should be the main functional group, and that functional group should get the lowest number possible. And not only that, all the substituents and the functional group supposed to get the most possible lower numbers. In that way, you have to number carbon atoms present in the given compound, and then start naming it with its position, and the substituents should be arranged according to the alphabetical order, and then last the parent chain. Okay, that's it. So we can move to the second question. It's just opposite to that of naming, IUPAC naming. Here the IUPAC name is given and you have to write the structure. So we can see, write structure of the following compound. What is the name given? 1 bromo, 4 sec-butyl, 2 methyl benzene. So what we have to do? So here we have the parent chain here. That is benzene. The rest of the things are substituents. So the parent chain is the basic skeleton of that given name. So we have to draw that first. So benzene is drawn. Okay, parent chain is drawn. And then on the parent chain we have different substituents that we can substitute according to the position. And we have 1 bromo at the first position. In the position number 1 on the carbon 1 we have a bromine. So let's just assign this as a carbon 1. So I have written this bromine. Okay, that is set. 1. Now we have decided it, this carbon as 1. So we can have 1, 2, 3, 4, 5 and 6. Okay, this is the numbering. Now let's see 4 sec-butyl. That means butyl means we have a small chain containing 4 carbon atoms, and sec-butyl among that 4 carbon atoms. Okay, we'll write a butyl CH3, CH2, CH2, CH3. And in the second carbon is connected with sec-butyl. Is write it. So here CH2, CH2, CH3 and CH3. So this is 4-sec-butyl. In the fourth position we have a butane group. It's a 4-sec-butyl, and then 2-methyl-benzene. That means in the second position we have a methyl group, CH3, methyl group. So that's it. 1 bromo, 4-sec-butyl. In the second carbon is attached with the benzene ring. 1 bromo, 4-sec-butyl, 2-methyl-benzene. That's it. This is also an FAQ. So you have to practice it, and this will help you to answer any questions that comes in this type. An IUPAC name is given and you have to write the structure. First you have to consider the parent chain. Write the parent chain first, because everything based on the parent skeleton, okay? So the parent chain you have to write first, and then you have to assign the substituents according to the given order given. That means the position of the substituents on which carbon will be specified. Accordingly, you have to give position for the substituents. That's all. It's easy, right? Okay. Now let's move to the next question. Write the structure of an isomer of compound C4H9Br, which is most reactive towards SN1 reactions. So it's a bit confusing question at the first sight. So what you have to do is, whenever you get a question, you have to read it again and again, which will give you clear-cut ideas to move to the correct answer. So what do you have to think? This particular question is speaking about SN1 reaction and its reactivity. And you know very well, in the case of SN1 reactions, tertiary halides are more reactive than secondary halides. Secondary halides are more reactive than primary halides. So it is in this order: tertiary greater than secondary greater than primary. This is the order of alkyl halides when coming in the case of reactivity in the case of SN1 reactions. That we have to keep in mind. And the given compound is C4H9Br. So what is the question given? Write the structure of an isomer of compound C4H9Br, which is most reactive towards SN1 reactions. So first we have to know what is this compound. So write the compound C4H9Br. Okay. So let's see. Let's make it simple. So C4 carbon atoms are there. C. This we all know what is C4H9Br. So just give this CH3, CH2, CH2, CH3. So we have written C4H9. Sorry, Br also we have to add here. So CH2Br. This is the compound given. Okay. And in this form you cannot think about this particular compound reacting in or participating in an SN1 reaction. So we have to get a more stable carbocation by taking a tertiary halide. So we have to arrange it in its tertiary form. How do you write it? So here we can arrange it in any way, right? One C I have taken here. Then we have 3 other alkyl groups like CH3, I have written, and then we have Br here. So 1, 2, 3, 4 C4, 3, 6, 9 H9 Br. Okay, so this is the compound. This is the isomer of the given compound, which is the most reactive towards SN1 reaction because it is tertiary. That's all. Very simple. Yeah. So if you do practice makes one perfect. So do it. Practice as many number of questions which you can practice. So going on practicing, that will make you give or that will help you to give answer by reading the question and coming to a conclusion how to write an answer in a best way. So practice it. Practice maximum questions. Okay. Let's see the next question. Out of ethyl bromide and ethyl chloride, which has higher boiling point? So we have given here two type of alkyl halides, two alkyl halides, ethyl bromide and ethyl chloride. Okay, CH3, CH2, Br, ethyl bromide, CH3, CH2, Cl, ethyl chloride. Here what you have to keep in mind is the alkyl group is same in both the cases. What is different here? Only the halide is different. Here it is Br and here it is Cl. Okay. So we have already learned what you have learned. If alkyl group is same, still the boiling point can be changed for the alkyl halides because of the change in halogen atoms. According to the halogen atom present in that given compound, it will change. How it will change? We can write it like this. RF, alkyl fluoride, then will have the least boiling point, then RCl, then RBr, okay, fluorine, chlorine, bromine, iodine and so on. So Ri. So which is having the highest boiling point here? The one with the biggest halogen atom. So here when considering ethyl bromide and ethyl chloride, which will be having the highest boiling point? Ethyl bromide is going to have the highest boiling point, because here according to this order it is correct. Ethyl bromide will have a better boiling point than ethyl chloride, right? So we will select it as this ethyl bromide is CH3, CH2, Br will be having better boiling point, will be having the highest boiling point when comparing with the higher boiling point when comparing with the ethyl chloride. Why? When the size and mass of halogen atom increases, mass of halogen atom increases, the attraction due to, the one, or we can write the van der Waals forces of attraction increases. That should be the reason. You have to, if a reason is needed, you have to write this. So what you have to do, if same type of two different types or three different types of alkyl halides are given and you have to opt for the one with the highest boiling point, what you have to do, if the alkyl groups are same in the given compounds, you have to look for the halogen atom. If which will be the biggest halogen atom that will be having the mass more, it will be having more mass than the other ones, and that will be having more van der Waals forces of attraction, and so that will be having the highest boiling point. And so here we will have ethyl bromide with higher boiling point than ethyl chloride, or you can just rely on this particular order of arrangement of increasing boiling point, and you can take and you can select the one with the higher boiling point. Anyway, according to your convenience, you can give the answer. Okay. So let's move to the next question. In the following pair of halogen compounds, which would undergo SN2 reaction faster? So SN2 reaction, you know, it is according to just opposite to that of SN1 reaction. Primary will undergo faster than secondary, then tertiary. Anyway, that is not the case here because we don't have any primary, secondary specified here. But one thing we have here. SN2 reaction is based on the ability to leave the leaving group. The better leaving group will undergo SN2 reaction faster. So, very easily we can sort out which one will undergo SN2 reaction faster. Since iodine being the big halogen, the bigger ones will tend to leave fast. So, iodine will be the better leaving group. So, here iodine will be the better leaving group. So, second one will undergo SN2 reaction faster. So, in this case, if same type of compound is given with different halogen, you have to see the size of the halogen, which is the bigger halogen. So, that halogen will be leaving the group faster when the nucleophile approaches. So, the better leaving group constitute faster SN2 reaction. So, the second compound which is containing iodine will be undergoing SN2 reaction more faster. So, we have made a quick revision of half of the portions considering haloalkanes and haloarenes. So, we will come up with better explanations and FAQs in the next video. See you again. Thank you.